This is SpaceTime Series 25, Episode 119, for broadcast on the 7th of November 2022. Coming up on SpaceTime, a giant asteroid discovered just a day before it flew past the Earth, finding the origins of the oldest known Martian meteorite, and another giant piece of space junk headed for Earth. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
Astronomers discovered a huge asteroid as big as a skyscraper just a day before it zoomed right by the Earth. This massive 740-metre-wide space rock, named 2022 RM4, was first detected on Halloween, October 31st, and then it streaked past the Earth the following day, November 1st. The asteroid was discovered by the Virtual Telescope project as it was heading towards our planet when it was just 3.1 million kilometres away. NASA estimates that the potentially hazardous asteroid was travelling at a speed of around 84,500 kilometres per hour, or to put that another way, 68 times the speed of sound. It eventually passed the Earth at a distance of 2.3 million kilometres. Now, by cosmic standards, that's a very slender margin. In fact, the asteroid was close enough to be easily visible in backyard telescopes. This is Space-Time. Still to come, discovering the origins of the oldest known Martian meteorite on Earth, and seeing some of the oldest star clusters in the universe. All that and more still to come on Space-Time. Scientists have been able to locate the exact point of origin of the oldest and most famous Martian meteorite ever found on Earth. The 320-kilogram black-coloured rock, catalogued as Martian Meteorite NWA7034 and commonly known as Black Beauty, together with some other fragments, was found in northern Africa in 2011. Now, the discovery of its Martian origin, reported in the journal Nature Communications, offers critical new geological clues about the surface of ancient Mars. The authors used a multidisciplinary approach involving a machine learning algorithm in order to track the specific impact crater on the Martian surface from which this meteorite was originally ejected into space. The scientists have now named the specific Martian crater after the Pilbara city of Karratha, located 1,500 kilometres north of Perth in Western Australia, which is home to one of the oldest known Earth rocks. The study's lead author, Anthony Legain from Curtin University, says the discoveries offered never-before-known details about Black Beauty, which has already been widely studied across the globe. As well as being the oldest known Martian meteorite, Black Beauty is also the only known brecciated Martian example available on Earth. That means it contains angular fragments of multiple different rock types which have all been cemented together, and that's different from all other known Martian meteorites on Earth, which contain just a single rock type. Legain says it's the first time scientists have been able to know the geological context of the only brecciated Martian sample available on Earth. And it's happened 10 years before NASA's Mars Sample Return mission is set to send back samples collected on the Red Planet by the Perseverance rover, which is currently exploring Jezero Crater. He says finding the region where the Black Beauty meteorite originated was crucial because it contains the oldest Martian fragments ever found, aged around 4.48 billion years. And it consequently shows similarities between Mars's very oldest crust, aged about 4.53 billion years, and Earth's continents today. So the region they identified as being the source of this unique Martian meteorite sample constitutes a true window into the very earliest environments of the planets, including the Earth, a window which our planet has lost because of plate tectonics and erosion. Legain says this research also paves the way to locate the ejection sites of other Martian meteorites. And these will join together to create the most extensive view yet of the red planet's geological history.
We've got plenty of Martian meteorites on Earth, about 300 actually, coming from Mars, and they constitute the only samples we've got on Earth to study in details the geological history of Mars. But the thing is, until now, we didn't know where these meteorites came from on the surface of Mars. And now we studied Black Beauty, and we wanted to know where exactly this meteorite came from to understand a bit better how this rock formed. And basically, Black Beauty is the only Martian meteorite that contains such old components. So within Black Beauty, we've got some zircons, some minerals that are as old as 4.48 billion years old. And they constitute a true window towards the understanding of the past, of the early evolution of Mars and also the Earth, because on Earth we do not have such old rock.
Yes, plate tectonics can be a bitch.
Yeah, that's the thing. On Earth we've got plate tectonics, we've got a lot of erosion, and it's very, very difficult to find very old rocks, older than 4 billion years old on the surface of the Earth due to these processes. But on Mars, it's not the case. Most of the surface, I would say that the half of the surface is very old, older than 4 billion years old. And having Black Beauty here in laboratory on Earth is amazing because we can study the early evolution of Mars and the Earth in detail and understand a bit better how planets formed at the very beginning of the solar system.
So what part of Mars did this come from?
So this meteorite is coming from the province we call Terra Cimmeria Sirenum. It's a very old province in the southern hemisphere. It contains a lot of impact craters. One important thing to know is that when you study planetary surfaces, if you are able to identify a lot of impact crater on the surface, it means that this surface is very, very old because it has been exposed a very long time to the meteoritic bombardment. So Black Beauty is coming from typically this kind of surface, very old surface. And when we analyzed the distribution of millions of impact craters to understand a bit better where this meteorite came from, we realized that actually Black Beauty came from an impact crater we called Carata. And this impact crater is superposed on what we call the ejecta blanket, so the material that has been excavated from an older impact crater, about 1.5 billion years old, on top of this old terrain that is probably as old as 4.5 billion years old.
So there was a original crater there, and then the asteroid which hit Mars to create this meteor then slammed into that crater, excavating that material, blasting that into space, and it was a piece of this rock, this ejecta, which eventually made its way to Earth.
Exactly. It's a pretty complicated story. But it's not surprising because Black Beauty is the only breccia, the only Martian meteorite that is a breccia. So breccia is basically composed by a bunch of other rocks, and usually other Martian meteorites are typically basalt, the kind of rock you can find on the flank of a volcano on Earth. But for Black Beauty, it's completely different. This meteorite is completely unique. So due to the nature of this meteorite, the breccia, we thought that it will represent probably the ejecta material of an older crater, and that's what we found. So it's pretty consistent. The meteorite Black Beauty is the only meteorite that shows such concentrations in potassium and thorium and such magnetism. So this meteorite is magnetic, and the other Martian meteorites we've got are not, and they are pretty low in potassium and thorium. So we were after a region that shows a very high concentration of potassium and thorium and also a magnetic anomaly. And this region, Terra Cimmeria Sirenum, exhibits the three characteristics I just mentioned. So typically, it makes sense that this meteorite is coming from that particular province.
Do you know when this meteorite reached Earth?
So Black Beauty, we estimate that Black Beauty was ejected from the surface of Mars 5-10 million years ago. So it's quite recent compared to the entire geological history of Mars and the solar system. And then it traveled for about 5-10 million years before crossing the orbit of the Earth and became a meteorite. So it has been discovered in 2011, and then the meteorite was booked by a collectioner in 2012. And in 2013, the first study came out claiming that this meteorite came from Mars.
Yeah, I remember writing a story on it back then when that happened.
Oh, really?
Yeah, just lets me know how old I am. Thank you.
Sorry. That's important for the story. The most important thing is that this meteorite contains the oldest material we've been able to date that came from Mars, and that tells us that the properties of the meteorite is quite unique, and because it's coming from a unique province, Terra Cimmeria Serenum, that shows very interesting characteristics, now we can understand a bit better how this province formed. So typically, we can claim that very old rocks, pretty much as old as the planet itself, just below the ground in this province, and they probably formed very early in the history of the planet compared to the other material we are able to find on older surface that might have been formed later in the history of Mars. So that means the crust of Mars didn't form at the same time everywhere. You have to imagine that at the time that Mars formed, it was a kind of molten ball impacted by a bunch of large asteroids, and this molten ball cooled down at some point very, very early in the history of the planet. And this part of the history of planetary formation is not very well understood. We don't know, for example, if at the very beginning there was a kind of magma ocean, or if it was only partial, like if there was on the surface some magma seas or magma lakes. We don't know if it was partial or global. And this has a lot of implications to understand how plate tectonics formed, for instance.
Because this rock's so old and because we know how it formed, it's giving us a picture of one area of Mars. When we look at the entire planet, there's not much evidence of plate tectonics ever having occurred there.
Absolutely.
This would reinforce that, wouldn't it?
Yeah, absolutely. The thing is, we are not able to say that there was any plate tectonics at the beginning right now. And that's why it's very important to send some missions to investigate a bit more this area, collect samples and analyze them in situ so we can understand a bit better what happened at the time on Mars. If there was a bit of liquid water very early, 4.4, 4.3 billion years ago on the surface. So for the moment, all NASA missions or ESA missions are focusing on the search of liquid water on the surface of Mars and potential presence of life, but on terrains that are much younger than that. It will be very, very interesting to understand a bit more the geological history in the first hundreds of million years of the planet.
Now, as part of the process to understand Black Beauty, you guys used the supercomputer in Perth.
Yeah, so the thing is, we were after a very young crater. As I said, Karata, all the Martian meteorites were ejected from the surface 5-10 million years old, or at least less than 20 million years old from an impact. So we were after a very young impact, an impact larger than 3 kilometers to be able to eject rocks in space. And since we are not able to land on the surface of Mars and date every single impact crater is larger than 3 kilometers, there are approximately 80,000 of them on the surface. So we had to find a way to identify the youngest craters of that size formed on the surface of Mars. And for this, we used a machine learning technique, a crater detection algorithm, run on the POSI Supercomputing Center in Perth. And with this crater detection algorithm and the very high resolution images we've got from Mars, we've been able to identify about 94 million impact craters on the surface. And when you analyze the distribution of these craters, you find that most of the small craters, smaller than 100 meters on the surface, are not homogeneously distributed on the surface. They are concentrated around a couple of large impact craters, and actually these small craters are the product of the fallback of debris following the formation of large impact craters, and that's how we've been able to identify the youngest impact craters and large craters formed on the surface. And among the 19 large craters we've been able to identify thanks to this technique, but one of them was the most likely source of Black Beauty.
That's Anthony Legain from Curtin University. And this is SpaceTime. Still to come. Seeing the oldest star clusters in the universe, another giant piece of space junk heading towards the Earth thanks to China, and later in the science report, a new study shows that temperatures across Europe have been increasing at more than twice the global average. All that and more still to come on SpaceTime. Astronomers have identified the most distant and hence oldest globular star clusters ever seen. The discovery in an early analysis of NASA's James Webb Space Telescope's first deep field image depicts some of the universe's very earliest galaxies. In fact, the findings reported in the astrophysical journal Letters may be showing astronomers relics containing the first and oldest stars in the universe. The space-based infrared observatory, located 1.6 million kilometres from Earth on the planet's night side, was built to find the first stars and galaxies to come into existence, and to help astronomers understand the origins of complexity in the universe, such as the chemical elements and the building blocks of life. Webb's first finely detailed deep-field image has now allowed astronomers to zero in on what they've dubbed the Sparkler Galaxy. It's located around 9 billion light-years away. That's about 3/4 of the way back to the beginning of time. The galaxy got its name for the compact objects appearing as small yellow-reddish dots which surround it and which are being referred to by the authors as sparkles. They've hypothesized that these sparkles could either be very young clusters actively forming new stars, born during the peak of star formation, about 3 billion years after the Big Bang, some 13.82 billion years ago, or they're much older globular clusters. Globular clusters are ancient collections of stars tightly packed into spherical formations and held together by their collective gravity. They're thought to have been either formed at the same time in the same molecular gas and dust clouds, or alternatively, they're the centres of very ancient galaxies that have been ripped apart through their amalgamation with larger galaxies. From their initial analysis of 12 of these compact objects, or sparkles, the authors determined that 5 of them aren't only globular clusters, but they're among the oldest globular clusters ever seen. One of the study's authors, Catherine Lyer from the University of Toronto, says discovering such old globular clusters around distant galaxies simply wouldn't have been possible with previous Hubble telescope imaging. Lyer says thanks to Webb, they could observe these sparkles across a wide range of wavelengths. They could model them and then better understand their physical properties, things like how old they are and how many stars they contain. Our own galaxy, the Milky Way, is known to contain about 150 globular clusters, all made up of very ancient stars. But exactly how and when these dense clumps of stars formed isn't well understood. Astronomers know that globular clusters can be extremely old, but it's still incredibly challenging to actually measure their ages. Using very distant globular clusters to age date the first stars in distant galaxies hasn't been done before, and it's only been possible thanks to Webb. And somewhat counterintuitively, because the Sparkler Galaxy is much further away than our own Milky Way galaxy, it's actually easier to determine the ages of its globular clusters. You see, the authors are observing the sparkler as it was 9 billion years ago. That's a time when the universe was only 4.5 billion years old. So we're looking at something that happened an awful long time ago. It's a bit like guessing a person's age based on their appearance. Now, it's fairly easy to tell the difference between a 5-year-old and a 10-year-old, but it's a lot harder to tell the difference between someone aged, say, 50 compared to someone aged 55. Until now, astronomers simply couldn't see the surrounding compact objects of the Sparkler Galaxy simply using the Hubble Space Telescope. But this has changed thanks to Webb's increased resolution and sensitivity. It's unveiled the tiny dots surrounding the galaxy in detail for the first time. And the Sparkler Galaxy is special because it's magnified by a factor of about 100 due to an effect called gravitational lensing. That happens when the mass of a large object, in this case the MAX 0723 galaxy cluster, which is located in the foreground between us and the Sparkler Galaxy, acts as a sort of lens, distorting and magnifying the objects behind it, thanks to general relativity and the effect mass has on the bending of light. Even better, the gravitational lensing effect produced 3 separate images of the sparkler, allowing astronomers to study the galaxy in great detail. The authors combined the new data from Webb's near-infrared camera with the Hubble archival data, and the combined observations confirmed that the objects were in fact old globular clusters. The confirmation came from the lack of any oxygen emission lines. That is, emissions with measurable spectra which are given off by young star clusters that are actively forming new stars. And seeing several of Sparkler's globular clusters imaged 3 times made it clear that they were in fact orbiting around the Sparkler Galaxy rather than simply being in front of it by chance. It really is a new window of the universe opening up for astronomy. Another piece of giant Chinese space junk is now falling uncontrollably back to Earth, and no one has any idea where it's going to hit. The debris is a spent rocket stage from Beijing's recent launch of the third module of the Tiangong, or Celestial Palace, space station. The mission had taken off aboard a Long March 5B rocket from the Wenchang Satellite Launch Center on Hainan Island in the South China Sea. The problem is the Long March 5B's YF-77 liquid-fueled engines can't be restarted once they're shut down in orbit, so mission managers can't use them to guide the disused rocket into a safe drop zone. So the 23-ton vehicles are simply left to plummet uncontrollably back to Earth wherever they want, often barely missing towns or villages. And because of the uncontrolled nature of their deorbit and re-entry, people on the ground can't be warned in advance of the impending danger they're in. The widely spinning rocket body's orbit will simply gradually decay as its orbital speed reduces due to atmospheric drag. And the rate of that orbital decay will depend on the ever-changing density of the atmosphere which the spacecraft is travelling through. And that density depends on the strength of the solar wind at that point. The spent rocket body will simply bounce and surf along the upper layers of the atmosphere for a short while before it digs in deep enough to begin its final plunge down towards the planet's surface. And because of all these variables, scientists won't know when that happens until it happens. China has become a regular offender of this dangerous type of uncontrolled deorbit, and it's been highly criticised by other spacefaring nations because of it. In fact, just last July, a spent Long March 5B crashed into the Indian Ocean in the Sulawesi Sea between the Western Philippines and Borneo in another uncontrolled deorbit. And there was another Long March 5B which fell into the Indian Ocean off the coast of the Maldives in April 2021. That was after yet another uncontrolled deorbit. And in 2020, huge chunks of a Long March 5B crashed to Earth on the Ivory Coast, damaging buildings in several villages. As for the mission's payload, the new Mengtian, or Celestial Dream module, has now docked onto the Tianhe and Wentian modules to complete the basic structure of China's new space station. Beijing says the 20-ton Mengtian will provide room for scientific experiments in zero gravity. The 18-metre-long, 4.2-metre diameter module is equipped with an airlock for exposure to the vacuum of space and a small robotic arm to support extravehicular payloads. The new addition gives the space station some 110 cubic metres of pressurised interior space. Following Mengtian's arrival, an unmanned Tianzhu cargo ship is slated to dock to the space station later this month, followed by a new crew of taikonauts aboard a Shenzhou capsule in December. Meanwhile, China's launched yet another new classified military spy satellite into orbit, this one designed for electronic surveillance and reconnaissance. The Xian-20C was launched aboard a Long March 2D rocket from the Zhuquan Satellite Launch Center in northwestern China. The 1,200-kilogram electronic signals intelligence gathering spacecraft was placed into a 700-kilometre high orbit. Beijing claims the satellite will mainly be used for in-orbit verification of new technologies, such as space environment monitoring. They say it's an experimental satellite. But the simple fact is it's now part of a constellation made up of some 22 similar satellites. China now has an estimated 553 satellites orbiting the Earth. That includes some 229 Earth observation, surveillance or reconnaissance satellites, including at least 41 Gaofeng and some 107 Yaogang spy satellites. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that temperatures across Europe have increased at more than twice the global average rate over the past 30 years. The findings, contained in a new report by the World Meteorological Organization, show that Europe is the fastest warming continent in the world. The State of Climate in Europe report outlines ice loss in alpine glaciers in Greenland, which are contributing to sea level rise. In 2021, hundreds of Europeans died and the economy lost more than $50 billion in damages, all due to climate change-related events, the majority of which involved events like floods, storms and heat waves. Scientists have found that around a third of people whose COVID-19 symptoms have cleared up are reporting that at least some of their symptoms are returning. The findings, reported in the Journal of the American Medical Association, are based on a study tracking symptoms over 29 days in around 150 people who had COVID-19 and were only receiving a placebo as part of a clinical trial of COVID-19 treatments. They found that people's symptoms are inherently subjective and that the most common recurring symptoms were coughs, fatigue and headaches. The authors say this rebounding of symptoms in untreated COVID-19 patients may also explain some of the rebound symptoms doctors are seeing in patients after treatment for COVID-19 with drugs like Paxlovid. The latest revised figures suggest that some 6.6 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization says the true death toll is likely to be over 15 million, with some 636 million confirmed cases globally. While the Lancet Commission, a panel of world-leading experts in policy and disease management, estimates around 18 million people have now died because of COVID-19. The diabetes drug Ozempic, which has become a viral hit in social media for weight loss, has now been shown to be effective in reducing body mass index in obese teens. The findings, reported in the New England Journal of Medicine, are based on a small study of around 200 teenagers. The authors found that after just over a year, around 73% of people taking the drug had weight loss of around 5% or more. That compared to just 18% of people taking a placebo. The pseudoscience of Reiki is making a comeback among so-called holistic healers. Reiki is a Japanese word meaning universal life energy, and that really should be your first warning sign. Practitioners say the true essence of Reiki is the pure light that permeates everything that exists in the universe. It's the energy of love, harmony and healing, and that should be your second warning sign. Those pushing the treatment claim it creates a balance due to the harmonization of the different energy centers or chakras in the body. And if your alarm bells weren't ringing by now, they probably never will. See, the thing is, despite extensive research, dissection, x-rays and examination, medical science has never been able to identify a chakra in the human body. Of course, that could be because different Reiki practitioners point to different parts of the body. Some say there are 6, others say 7, and still others insist there are 12. And the meridian lines through which the energy or chi flows have proven to be just as elusive, and for the same reasons. No one can quite agree as to where they are. Tim Mendham from Australian Skeptics says Reiki is such an infamous pseudoscience, it's used as an illustrative example of pseudoscience in academic text and academic journal articles.
Reiki is the pseudo-medical treatment for all sorts of conditions, especially stress areas. It is basically you lie down on a table and the practitioner moves their hands back and forth over you. They do not touch, normally anyway. They do not touch. They just wiggle their fingers and move their hands up and down across your body and then dump out the bad energy. Now, someone pointed out to me, don't stand at the end because you're going to get dumped with all the bad energy. It's a system which is a pseudoscience. It's classic sort of pseudo-medicine, and there's nothing to it. It talks about the usual rat-bag science of energies and chakras and improving your balance and centering and sort of improves your emotional state. Maybe if someone's moving their hands above your body, it does make it feel calmer. That's C-A-L-M-E-R, not K-A-R-M-A. And so therefore, then that's not going to last very long. And it certainly doesn't actually do anything for you, but they say it does. They say it actually does, apart from balancing your energies and things like that, they say it can have some curative
Well, that's the placebo effect, isn't it?
Yeah, yes, like a lot of things. You see these articles and things, and looking at one in particular recently came out, actually, which was saying that the wonderful thing that Reiki is a pseudoscience and doesn't work, but it works. I don't think this even mentions placebo effect. It's one of these classic pseudo-medical paranormal beliefs that needs no real evidence. I don't know how many people have actually done studies on the effectiveness of Reiki. It's probably not of great interest to a lot of people because they can see no foundation to it, certainly no scientific foundation. There is no evidence at all, as if we needed evidence for this thing to suggest that moving your hands above someone is sort of going to balance their chakras and that sort of stuff. So Reiki has been around for a while, probably not as long as people think, like a lot of these things. Then they start adding details to it to make it sound a bit sort of more scientific. There's supposed to be 12 positions where you can place your hands, a bit like the meridians of acupuncture, things like that. So you've got to do it in certain places, from the head to the soles of the feet. And so you can, improve your vital energy. It's a pseudoscience through and through. It's a pseudo-medicine. Certainly not going to cure you of any real medical condition.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.